Jupiter is about to finish something it started before our species existed. For more than 100,000 years, its gravity, together with Saturn's, has been easing the shape of Earth's orbit toward a near-perfect circle, and our orbit is now almost as round as it ever gets. That single fact helps decide whether the next ice age arrives on schedule or is pushed back by tens of thousands of years. In 2025, the two studies finally measured which way it is tipping and found something new leaning on the scale. This is the story of the clock in the sky and the moment we reached up and touched it. The climate of this planet is not improvising. Stretch it across hundreds of thousands of years, and a pattern appears that has no business being there. Cold, then warm, then cold again. Glaciers grinding south across whole continents, then crawling back north over and over, with the regularity of something mechanical. Ice more than 3 kilometers thick, close to 2 miles of it, has buried the ground your city stands on, melted away, and buried it again. And the timing of all that freezing and thawing is not an accident. Something is keeping the beat. For most of the history of science, nobody could say what. The cold ages were obvious in the rock, in the scratched and gouged ground the old glaciers left behind. But the reason was a wall. What could reach out and freeze half a planet on a schedule, then warm it back again and again for millions of years? The answer is not on Earth. The answer is 2 planets you will never visit, holding our orbit in their gravity with a patience that makes recorded history look like a single afternoon. And right now, today, those 2 planets are doing something to Earth's orbit that the Ice Age record has not seen the likes of in a very long time. The first person to hear the rhythm was a man alone with arithmetic. Milutin Milanković, a Serbian engineer and mathematician, spent years, including a stretch as a prisoner of war during the First World War, filling notebooks with one of the most tedious calculations anyone has ever attempted by hand. No computer, no calculator, just page after page, working out century by century how the shape of Earth's orbit and the tilt of its axis slowly change over tens of thousands of years. He was chasing a single idea, that the ice ages are written in the geometry of how Earth moves around the Sun. He believed the deciding factor was not winter but summer, and specifically whether the sunlight falling on the far north in summer is strong enough to melt the previous winter's snow. When it is not, the snow survives, and it piles up, and it grows. Milanković died in 1958, decades before anyone could properly test him. For a while, plenty of scientists doubted it. Calculations about distant planets felt too tidy to explain something as unruly as a global climate, and yet the beat he predicted was already recorded, waiting, in the mud and the ice. We simply had not learned to read it yet. Earth does not move in a fixed, reliable way. 3 things about its motion drift on long cycles, and together they decide the ice. The tilt of its axis nods up and down between about 22 degrees and 24.5 degrees, on a cycle near 41,000 years. The axis itself wobbles like a spinning top, losing its balance, tracing a slow circle over roughly 26,000 years. And the shape of the orbit stretches from nearly circular to slightly oval and back again. Stack those 3 rhythms on top of each other, and you get the pattern that drives the ice. When they line up the wrong way, the far north stops getting enough summer sunlight to undo the winter. The snow survives the season. It piles up year after year, century after century, until it becomes a wall of ice. So the ice is not really about temperature the way you would guess. It is about geometry, about whether northern summers are warm enough to erase northern winters. Move the geometry and you move the ice, which raises the question that should be bothering you by now. What moves the geometry? Earth cannot do it to itself. The shape of Earth's orbit is not Earth's doing at all. It is the gravity of the other planets, pulling on us across hundreds of millions of kilometers. And the heaviest hands belong to the two largest planets in the solar system, Jupiter and Saturn. Let me make Jupiter's size real for a moment, because the word giant gets used until it means nothing. Jupiter is more than 2.5 times as massive as every other planet combined. Pour all 7 other worlds onto one side of a scale, and Jupiter still wins. More than 1,300 Earths could fit inside it. When something this heavy circles the Sun, its gravity reaches inward across the whole system, and it never stops pulling on us. Saturn is lighter, about 95 times the mass of Earth, and much farther out. But distance does not mean harmless. Over tens of thousands of years, its steady, repeated pull adds up. Think of Earth's orbit as a loop of wire, and Jupiter and Saturn as 2 hands slowly bending it. One eases it more oval, the other eases it back toward round. Neither hand rushes, neither lets go. And the result is that Earth's orbit is constantly breathing in and out of shape, on a cycle that runs about 100,000 years long. That beat is one of the strongest in the entire Ice Age record. The giants are not a footnote to our climate, they are among its authors, and distance does nothing to soften the grip. Sunlight itself takes more than 40 minutes to cross from the Sun out to Jupiter, and yet Jupiter's gravity still reaches all the way back to us all the time, setting by tiny amounts the shape of the path we travel. Gravity does not fade the way our instincts insist it should. It crosses the dark patiently, and it never lets go. Do not write Saturn off as the smaller partner. It matters out of all proportion to its mass, and the reason is a kind of cosmic rhythm called resonance. Jupiter and Saturn are locked in a slow gravitational conversation. For roughly every 5 trips Jupiter makes around the Sun, Saturn makes 2. Their closest approaches keep landing in nearly the same places, so their pulls do not cancel into noise. They reinforce. It is the same reason a child on a swing goes higher when you push at exactly the right moment instead of at random. 2 giants pushing in time can move things neither could move alone. On its own, Saturn could barely budge our orbit. Working in step with Jupiter, it becomes half the reason the 100,000-year beat exists at all. And Saturn carries a strangeness of its own. It is so light for its size that, in theory, if you could find a bathtub large enough, the whole planet would float. It is less dense than water. There is something worth sitting with in that. Part of the balance between ice and open ground on Earth is set by a planet you could not float a boat on, working together with a planet that would float in a bathtub, across the emptiness, with a patience no living thing could match. But knowing the giants keep a beat is not the same as proving it. So how do we know any of this is real? The proof arrived on 2 legs, and the second one should give you chills. The first leg is the mathematics. Scientists build models of the entire solar system, every major body and the gravity between them, and let those models run forward and backward across millions of years. They do not put the rhythms in by hand. The long cycles emerge on their own, purely from the gravity. Earth's orbital shape rises and falls in waves, with periods near 100,000 and 405,000 years. And those numbers fall right out of the pull of Jupiter, Saturn, and Venus. In 2018, Dennis Kent and Paul Olsen traced that 405,000-year beat back through more than 200 million years of rock, and found it had barely wavered. The giants keep excellent time. The second leg is the Earth itself. Drill into ancient seabed sediment and polar ice, and you find the climate cycles preserved like rings in a tree, bands of warm and cold stacked one on another. In 1976, James Hayes, John Imbrie, and Nicholas Shackleton measured those layers in ocean floor cores reaching back nearly 500,000 years. The rhythms were exactly where Milankovitch's geometry said they would be, near 23,000 years, near 41,000, near 100,000. Their paper carried a title that said the quiet part out loud. It called the orbit the pacemaker of the ice ages. We did not invent these cycles. We dug them up. The rocks had been keeping the record of Jupiter and Saturn for millions of years, written into layers laid down long before anyone was alive to read them, waiting for a species patient enough to notice. Here is where the story stops being ancient history and starts being about your own future. Because the orbital machine is not finished. It is doing something right now, and 2 studies published in 2025 have brought the picture into sharp focus. Earth's orbit at this moment is nearly round. Its eccentricity, the measure of how oval it is, sits near one of the lowest values it ever reaches, and it is still dropping. That is the giants at work, easing our orbit toward a circle. And a nearly circular orbit changes everything about the ice, because it quiets the wobble that usually drives the sharpest swings. Back in 2002, André Berger and Marie-France Lutrum looked at this and asked a startling question in the title of their paper, whether an exceptionally long warm period lay ahead. Their answer was that because eccentricity is near a minimum, the current warm interval could stretch on far longer than the recent pattern would suggest, on the order of 50,000 years. The closest match they could find in the whole record was a warm stretch about 400,000 years ago, the last time the orbit sat this quiet. An orbit this close to a circle, this calm, is a configuration the ice ages have not truly settled into in far longer than 100,000 years. In 2025, a team led by Stephen Barker, with Lorraine Lisiecki, Gregor Knorr and others, went further, matching the last several ice ages to the exact orbital states that triggered them. Left alone, they found, Earth's next glaciation would ordinarily begin within about 10 to 11,000 years, as the axial tilt slides toward its own minimum. And a second 2025 study, led by Van Breedam, modelled the next 200,000 years and reached a quieter, heavier conclusion. The natural clock may not get its turn at all. The carbon we have already put into the air, which lingers for tens of thousands of years, is enough to push the next ice age far past its scheduled arrival, by tens of thousands of years. For the first time in the history of life on Earth, a species is reaching up and holding down a hand on a planetary clock. That is the thing Jupiter and Saturn are doing right now that hasn't been matched in over 100,000 years, rounding our orbit into its quietest configuration, just as we begin, without meaning to override it. Let me pull you out of the numbers and set you down inside one of these cold ages, because the scale only becomes real when it is standing on top of you. Go back about 20,000 years to the last time the ice was at its worst. If you lived anywhere across the northern half of the world, picture the ground beneath your feet, buried under a wall of ice, taller than the tallest building in your city. Not a glacier you would hike to. A frozen ceiling pressing down on the land where your home is, in places more than 3 kilometers thick, close to 2 miles of solid ice, grinding slowly south and scraping the ground flat as it moves. The air is bone dry and brutally cold. Nothing grows here. Whole forests are gone, replaced by a frozen plain that runs unbroken to the edge of sight. The sea has pulled back so far that beaches you know today would sit far inland. The shoreline retreated over the horizon. So much water is locked in the ice that the oceans have dropped by about 120 meters, close to 400 feet, and where there was sea, there are now land bridges that people walked across to reach new continents. And none of it was triggered by anything on Earth. The thing that decided your patch of the planet would freeze was the angle of the sunlight in the far north, set by a wobble and a stretch in Earth's orbit, nudged by 2 planets you could not have picked out in the daytime sky. That is what it means to say the giants keep the rhythm. It is not an abstraction. It is a wall of ice where your street is. Now hold that picture and look up at the planet that helped put it there. Jupiter is even stranger up close than it is from far away, and knowing what it actually is makes its grip on us harder to shrug off. It has no surface. None. Drop toward it and you would fall through pale ammonia clouds into a hydrogen atmosphere that grows thicker and hotter the further down you go, until the gas around you stops behaving like gas at all. Thousands of kilometers down, the hydrogen is squeezed so hard it turns into a liquid metal, an ocean of metallic hydrogen wrapping the core, a substance that exists nowhere on Earth. There is no line where atmosphere ends and ground begins. There is just more, and heavier, all the way down. When the Juno spacecraft arrived in 2016 and looked inside, it did not find the neat solid core we expected. It found something stranger, a diffuse, smeared-out center. Heavy elements worth several Earths blurred across a third or more of the planet, a core that never fully finished forming. And Jupiter is fast. It spins faster than any planet in the solar system. A full day there lasts under 10 hours, a ball more than 11 times wider than Earth turning so hard that it visibly bulges at its equator, flinging its own middle outward into space. It also leaks heat, glowing faintly with warmth left over from its birth 4.5 billion years ago, still slowly shrinking and releasing that ancient energy. Point even a small telescope at it, and one feature stares back. The Great Red Spot, a single storm wider than the entire Earth that has been turning for centuries, outliving every person who ever pointed a lens at it. And around the whole planet stretches a magnetic field so large that if your eyes could see it in our night sky, it would look bigger than the full moon. We learned much of this the hard way by throwing machines at it. Pioneer 10 flew through its radiation in 1973. The two Voyagers in 1979 caught its Munio covered in erupting volcanoes. And Galileo in 1995 dropped a probe straight into the clouds that radioed back for 58 minutes before the pressure destroyed it. Every one of those machines returned the same message. This planet is bigger, stranger, and more powerful than the calm picture in the textbook. Jupiter's grip on Earth's orbit is only the gentle edge of what it can do. Its real power shows up over immense stretches of time. Run the solar system forward far enough in those same simulations, billions of years out, and the orbits stop being perfectly predictable. Tiny nudges accumulate and feed on themselves. In work led by the astronomer Jacques Lascar, thousands of simulated futures were run out 5 billion years. And in about 1% of them, Mercury, the smallest planet, has its orbit stretched by a slow resonance with Jupiter until it destabilizes completely, thrown onto a path that could end in a collision with Venus or with the Sun. Let me be careful here because this is exactly the kind of fact that gets ripped out of context. The odds are low, around 1%, and the timeline runs past the point where the Sun itself begins to die. This is not a warning about anyone's lifetime, but it tells you what kind of object Jupiter is. It is not a neighbor. It is a slow, colossal engine of gravity that has been steering the fates of the other planets since before Earth had oceans. And that same engine, turned down to its gentlest setting, is the hand easing our orbit toward a circle right now. The hand helping decide when the ice comes back. The power that could one day unseat Mercury is the same power quietly pacing your climate the entire time. Step back and look at what we have actually uncovered. The stable, mild stretch of climate that let human civilization happen. The calm window where our ancestors stopped chasing herds and settled down to grow grain and build the first towns was not guaranteed. It was handed to us. We came out of the last ice age into a warm, steady interval, and we built everything we have inside it. Farming, cities, writing, every empire and every invention fits inside one warm gap between glaciations. And the length of that gap is shaped, in part, by where Jupiter and Saturn have nudged our orbit. The giants set the temperature of the room. We walked in and got comfortable with no idea who was holding the thermostat. And here is the turn that should stay with you. We have finally found the thermostat, and we have started leaning on it ourselves. The same carbon that warms the world today is, by the models, enough to skip the next scheduled ice age entirely. We are no longer only tenants of this rhythm. We have become, clumsily and half-aware, a second hand on the dial. The orbital clock is slow, measured in tens of thousands of years. What we are doing to the air is fast, measured in decades. Both are real. They simply run at completely different speeds, and that mismatch is the strange part. A hand that took hundreds of millions of years to learn the rhythm of the ice is being answered, for the first time, by a species that has known the rhythm exists for barely 50 years. The unsettling part was never the speed, it is the indifference. This machine does not know we exist. It was turning long before anything was alive to feel it, and it will keep turning long after the last trace of us is gone. The warmth that built our entire world was an arrangement of gravity we had no vote in and, until very recently, no power over. We are tenants in a house whose foundations shift on a schedule we can barely perceive, paying rent in time we did not know we owed. And yet, one curious species on one small rock learned to read the clock, pulled it out of pencil calculations and ice cores and layered cliffs, and understood, for the first time in the history of life here, just how much of our fragile, improbable story has always depended on giants we will never touch. Jupiter and Saturn have been keeping time since long before we had a word for it. They are doing it right now, holding our orbit at its roundest, pushing the ice further into the future than it has been in over 100,000 years. Nothing about it is violent. There is no impact, no explosion, no single night you could mark on a calendar. Just two giants out in the dark keeping time. And for one strange moment in the history of the universe, a world small enough to be shaped by them, and awake enough to watch the clock. Thanks for watching, and I'll see you in the next one.